So it is measured in milliliters. So 100 milliliter, right? So 9 gram, or would it be 0.9 gram? 0.9 gram per 100 milliliter. So you are right. It will be which, now if it is 0.9 in 100 milliliter, then that will mean 9 grams in 1000 milliliter. Right? So start reading this. So if we read this, 3% sodium chloride solution, what does that mean? That means 3 gram in percent in 100 milliliter, which will mean 30 grams in 1000 milliliters, right? So this 3% sodium chloride means 30 gram per liter. This 0.9% sodium chloride means 9 gram per liter. Make sense? So if I said 2% sodium chloride, that would mean what? 2 gram per 100 milliliter, and then 20 gram per 1000 milliliters, right? Because there are 10 100 milliliters in 1000. So if there is 2 gram per 100, then in 10 of hundreds there will be 20. Make sense? So the first thing is, we now know how to understand when we say 0.9% sodium chloride or 3% sodium chloride. Now let's see what is the osmolarity of this substance. So that's going to be very much fun. So let's do that. Okay. Sodium chloride, right? So 9 gram. If we know what is the 1 mole, what is the weight of a mole of sodium chloride, then we can see how many moles is this, right? For example, if I said 1 mole of sodium chloride is 9 gram, that means this is 1 mole, right? If I said 1 mole of sodium chloride is 18 gram, then this means it's half mole, right? If I said 1 mole of sodium chloride is 4.5 gram, then this would mean 2 moles, right? So what we have to understand now is what is the 1 mole sodium chloride's weight. So we talked about it a few minutes back. The sodium 1 mole is 22.9, chloride 1 mole is 33.5. So if we add them, so this is 5.4, this is 9.8. Anyways, if we add it, it comes to be about 58.5. 58.5 what? These are grams, right? So gram. So 58.5 gram of sodium chloride is 1 mole. Okay. So if we have 58.5 gram as 1 mole, then 9 gram is how much? So what we would do is we'll pick up 9 gram and we would divide it with 58.5 gram, and whatever that comes to be 0.15 something, that is the mole. 0.15 mole, or we can do the actual calculation, it would be something like that, 0.154 moles of sodium. So be careful what we're talking about. 0.9% sodium chloride means what? That means 9 gram of sodium per liter. If there was 58.5 gram of sodium in 1 liter of fluid, that would be called 1 molar solution. Instead, we have 9 grams, so we divide them and we come to be 0.14 molar solution. So 0.9% sodium chloride means 0.15 molar solution. Good? The osmolarity is 0.14 osmoles. Remember we talked about this, at mole when present in the fluid are called osmoles. So we have 0.15 osmoles. Okay. So stay with me. If it is 0.15 osmoles, then what would that mean? How many milliosmoles? Remember we said that for practical reasons we talk about them in the milliosmoles. So 1500 milliosmoles. right. So now we have the 150 milliosmoles, not 00. So 0. I think it is 154, yeah. So 150 milliosmoles. Now we know sodium chloride, if that is giving us 150 milliosmoles, and we put this in water, what is going to happen? It's going to dissociate into sodium and chloride. And how many number of particles? Equal number. What will those be? Equal number, 150 of sodium and 150 milliosmole of chloride. That would mean if I pick up this 150 multiplied with 2, that would be 300 milliosmoles. So 0.9% sodium chloride is actually 150 milliosmole sodium chloride, but because sodium chloride is going to dissociate into sodiums and chlorides, that would make 300 multiplied by 2. So 300 milliosmoles. Now as we talked last time, a few minutes back in our lecture, that basically all the sodium chloride does not dissociate, about 93% dissociates. So if you really want to be accurate, what you would do is you'll pick up the 300 and you'll take the 93% of it. So that would be 93 plus 93, so there are 300s in it, right? So 93% out of every 100, so 100, 100, 100, 93, 93, 93, so about 280 milliosmoles. If we apply the coefficient, that is why some books say about 200 milliosmoles and the other books say about 300 milliosmoles. It depends if they ignore the coefficient or not. So you can say that the range for the sodium chloride osmolarity inside the body is from 280 to 300, depending upon how much dissociated. Okay, now please remember this, that this is actually true for the extracellular fluid, that the osmolarity of the extracellular fluid is 200 milliosmoles, and the primary driver of that is, so this is ICF, this is ECF, vascular compartment, interstitial compartment. What I'm saying is that the osmolarity here is 200 milliosmoles, and it is primarily maintained by sodiums and chlorides. Good. Now remember this thing, we're talking about a semi-permeable membrane here. The cell membranes are semi-permeable membranes. That means if the osmolarity is different here, if the concentration of particles is different here, then the water is either going to move out or come in. Right? That is the whole point of doing this fluid system, to try to understand this. So if the osmolarity is 200 milliosmoles outside, and if somehow we have maintained the same osmolarity inside, then if one water comes in, then one water molecule will go out. It would be in equilibrium. We'll say that there is no net water movement, correct? But if you add or subtract, so let's say you add more sodium chloride here, you take the osmolarity to 300, you increase the osmolarity on this side, what would that mean? That would mean the water concentration now becomes more over here, because there are more solutes here, less water here, there are less solutes here, more water here. So now water is going to go from this side to this side. Remember the osmotic pressure? So the water is going to go from the higher concentration to the lower concentration to the point that these two would become equal again. Correct? So how much equal? Please remember, solute is not going to move. Solute is not going to move. That means this osmolarity is going to stay. How much water would move from here to here? Enough that the osmolarity here is going to become 300 as well. Right? So the water is going to move. So this compartment is going to shrink. This compartment is going to expand. That volume went from this side to this side because there was extra solute over here. Right? So okay, we'll continue with this discussion. We'll talk about the 3% sodium chloride and other things. We'll talk about glucose, and then we'll talk about the further measurements and pathological conditions. Okay, next lectures.